All right, the first thing that we're going to do, it said on number 17, and this was on page 55, it wanted you to arrange the terms so that the powers of x are in ascending order. Why is it important for them to say powers of x? Very good. You know to only use the x. All right, so I'm going to highlight that. What else should I highlight or underline? Ascending, because ascending means I go which way, y'all? Smallest to largest. So when I look at these terms, what I'm going to do is I'm just looking at the exponent of x, right? So what is this one? 2. What's the exponent here? 0, 3, and 1. All right, so I want the smallest to the largest. Now, on your test tomorrow, you're not going to tell me 0, 1, 2, 3. No, you tell me the term that matches it. You got it? So what term had x to the 0? 2. And then what comes next? Plus x plus 9x squared plus x cubed. Beautiful. And that's it. You're done. Do we change the signs ever when we are rearranging? No. You only would change a sign if it had an equal sign in the problem. Got it? Okay, now this is an extra one. Woohoo! I just made this one up. And it says arrange so that the powers of who? C. So that the powers of C are in what order? Okay, this is just to help you because you're going to have one of these on your test tomorrow. So powers of C, what does that mean that I'm looking at then? Only the C's. So what is my exponent of C here? 0. What about C here? 2. Here. 1 here. 3 and here. 4. So descending means I go what? Yes, biggest to smallest. So what is the greatest exponent I have of C? C to the 4th is what it's called. Okay, next what would we have? Plus 8c cubed. Then what? Beautiful. And then? And then plus 15. So they have to tell you powers of C, powers of whatever. If they do have one of these questions on the EOC and they want you to rearrange, more than likely it's going to be for powers of x. You got it? But just read in the directions to make sure. If they do not provide directions, you always assume it's x. Okay? But obviously it wouldn't be x if the problem just had b's in it, correct? Because if there's no x's, we can't rearrange it. Okay, we could rearrange in order to b, but not with respect to x. Okay, number 18, 19, and 20 was on page, I think it was 56. Okay, why are these different? Well, not just that they have parentheses. What's the most special thing about these problems? How do we know that they're being added or subtracted? What's in between? So whenever you see a minus sign or an addition sign in between, do we distribute those? No, we're just doing what? Good. And then what do we do mathematically? Combine like terms. Beautiful. Okay, so for number 18, the minus says, technically there's a -1, right? That's why I'm distributing. But what else is my other fast way I can say it? Just change the signs. Where? In the whole problem? Yes, after the minus sign. So this kid is going to stay. So he stays 3x squared minus 7x plus 5. Do not change him to a plus sign. This just says change all of the ones after me. You got it? So this would become a what then? Positive x squared, and what else? Negative 4x. Once again, if you do not like thinking of this as change all the signs, you can think of it as a -1 that you're distributing. You got it? Okay, so who are my like terms? Good. Our x squareds are like terms because they have to look exactly the same. Negative 7x and negative 4x. Yes, 5's just going to come down because he doesn't have a partner. Now, whenever we're looking at this problem, when we go to combine the like terms, do we do anything with our exponents? No. When's the only time? Good. When we distribute, or as we say, we're going to draw and show the rainbows, all right? Which we'll get to later. But 3, what number is understood right here? So 3 plus 1 is what, friends? 4 what? Squared. Do not say to the 4th, I will throw up. Got it? Now what do I do? Minus 11x, right? Because you do not change the last name unless you're distributing. And then drop plus 5. Raise your hand if you got this last night. Good. Oh, well, yeah, good point. There really shouldn't be an equal sign, but look, we'll just draw a little arrow. It's simplified. Okay. And it is in descending order. Good job. Okay, number 19. Now, whenever I go to write this, what do I need to write with my z's? Yes, you want to put lines through your z's. If you don't, it looks disgusting. You got it? So we put lines through the z's. So, for right here, we would have 7z squared plus z plus 1. And then what about here? Yes, we're going to change all the signs here. So plus 4z. Good job. Okay, then we're just going to do what, guys? Combine like terms. Now I'm going to highlight. So z squared. Who else? Beautiful. Good. Now, I'm going to tell you something. I cannot tell you how many people, when they see plain old numbers, they assume that's not like terms. But plain old numbers can always be combined. You got it? Okay, so, and plain old numbers, the mathematical term is constant. Everybody say constant. Yeah. Okay, beautiful. All right, so whenever I go to combine these, what's 7 minus 3? 4z squared, then what? How did y'all get plus 5z? Why did you say plus 5 and not plus 4? And there's an understood 1. So if it doesn't have it and you need to draw it, draw it. And then plus 4. Beautiful. Okay, now number 20 is simple because what's in between them? Just plus signs. So what does that mean? Do you change anything in your problem? No. In fact, all you do is just rewrite it without changing anything. And then combine like terms. You're correct. So 2c squared plus 7c. Okay. Who are my like terms? Beautiful. Who else? 7c and 9c. Negative 9c. I'm glad you said that. And 4 and 1. Let's do pink. Ooh. Oh. All right. So, what does 2c squared and a 1c squared give you? 7c minus 9c. 4 plus 1. Bam. Done. Raise your hand if you got that. Is anybody confused about adding and subtracting? All you do is combine like terms. Right? Sorry, number 20. My bad. Okay, we're going to move on to number 8, which is on page 57 of your packet. And I'm going to go ahead and I'm going to kind of close this. That way we can see it a little bit better. Now, what is different? Well, actually, what is different between 8 and 18 as compared to 18, 19, and 20? What does 18, 19, and 20 have that 8 and 18 do not? Good. They don't have an operation sign in between it, right? The only thing it has is 7c times, right next to parentheses. What does that mean that we have to do then? Good. Distribute or make rainbows. That is correct. Yes. No, 8 and 18 is what we're doing. Okay, so for number 8, now when we keep talking about rainbows, I'm talking about when you distribute and you're drawing your beautiful little bitty arches. You got it? Now, what's special about rainbows? For rainbows, this is the only time ever that we will be adding our exponents together. So what is 7 times 5, friends? 35c. How did y'all get the c? Good. There's only one c, right? Okay. Over here now, what's 7 times negative 2? Is it c squared? It's c cubed. You have 2, and how many do you have here? So that's 3 total. And then, over here, what's 7 times, what's understood right here? A 1. What's 7 times 1? And how come it's c to the fourth? You had 3 c's, you have 1 c, so that's to the fourth. Your last step is always to combine like terms. But when we combine like terms, do we ever change our exponents? No, only when you're literally drawing the rainbows do you change them. Got it? Okay, so just a free question. What order is this polynomial in? Ascending. Ooh, y'all smart. Okay, number 18. Why does number 18 look weird? What do you think we have to do? Yes, you're just bring the 9a down. Who am I just going to distribute the 4a to? Only what's in the parentheses. This is the only thing he wants to multiply to. That's why he's hugging them. He's putting his arms around only these two. 9a, don't want. All right? So what is 4? Let's do our first rainbow. Oh, awesome. So 20a cubed, because you add your a's together, 1 and 2. What's 4 times negative 4? A. And then what do I just do with this 9a? What is the last step you should always be doing on these problems? Who are my like terms? Not 16a, negative 16a, and 9a. Now when I combine like terms, am I going to say a squared? No. When's the only time you would say a squared? Good, when you're distributing or rainbows. Okay, so that would be 20a cubed minus 7a. Raise your hand if you got that. I think you're going to make a 100 on this test tomorrow. Okay, let's move on. And this is on page, is it page 59? Yeah. These problems came from the bottom of the worksheet. They're not at the top. Page 59 was at the bottom. Got it? Remember how we talked about that yesterday? Page 58 is at the top, 59 is at the bottom. All right. Yeah, you started from the bottom now. All our math problems here. All right, whatever. Okay, number 13. What do I need to do? What would I need to do before I even work this problem? Good job. This means there's identical twins, right? So we have 2 of them, just like you said. And it's 6 plus u times 6 plus u. All right, and then what do I do again? How come I know I need to distribute? Good. There's nothing in between here. They're stuck to each other. You got it? So whenever we go to distribute, remember we do this term to everything in this parentheses. Then we come back here and distribute it to everything in this parentheses, right? Then combine like terms. That's it. All right, so what is 6 times 6, friends? Okay, now, what is 6 times u? 6u. Raise your hand if you understand why it's 6u. Real quick, it's because there's an understood 1. 6 times 1 is 6. And then it only has 1 u in between this term and this term. So 6u. Are we finished? No, because you have to distribute everything in the first parentheses. So I'm going to do this in a second color. So I'm going to come around here. What is u times 6 again? And what is u times u? Beautiful. 1u squared. Should we write the 1 in front of the u? No, just write u squared. You got it? Do you see why we wouldn't write the 1? Because it's understood. Now, our last step is to just do combine like terms. Who are my like terms? And that would give me what? So 36 plus 12u plus u squared. What does it give you? Did you like that? Ha ha ha. Okay. Any questions about that one? Okay. Our next one, number 21. I love this one. It makes people think. It just makes people think. All right. So for this one, what should we do? Write them how many times? Twice. So beautiful. X minus 4y times x minus 4y. Now I want you to watch closely for this one. And look, just so it doesn't confuse you, I'm going to hide this part. Okay, I'm going to go ahead and distribute. What is x times x? Good. We don't need to write 1x squared, right? Just x squared. All right, this one, watch very closely. What is understood in front of this x? What is 1 times negative 4? And why do we write xy? Beautiful. You put them together, and in what order do we put them together? What's that called? Alphabetical order. Good. You got it? Yes, ma'am. You are thinking of something else. You're thinking of, like, you can multiply x and y. You're thinking it's linear. No, this will not be linear because x and y are multiplied together, but that's something totally different. Just forget that. Don't forget it. But that is linear. Yes, like Destiny said, that's somewhere over the rainbow, huh? Mm-hmm. That's beautiful, though. I'm glad because that means that it's getting into your brain. So if they did ask you which one is linear, you'd be able to tell. Obviously, is this problem going to be linear? No. Not only is x, y, what else makes it not linear? An exponent. Look at y'all tying stuff in. That's a very common core of you. Okay, we're going to come back. Let's finish this problem real quick since we digressed. And x times x was x squared. So x times that was negative 4x. What's this guy going to be right here? Negative 4xy. And then what about this guy? Positive 16y squared. Beautiful. Now, what's our last step? Combine like terms. Who are my like terms? Good. What does that give you? It would be negative 8, and this stays the same, xy, plus 16y squared. All you're doing is combining like terms and keeping the same last name. That's what we called it. The only time you add exponents together is when you're distributing, when you're making a rainbow. Okay, let's do number 22 together, and then we'll be done. 22. Moving on to 22. All right, what does this tell us that we have to do? All right, what is 3b times 3b? What is 3b times negative 7? And then what's this guy going to be? Plus 21b. And then minus 49. Now stop right here. Here's a common algebra 1 mistake. People see 7 times negative 7, and you know what they tell me it is? You're right. They tell me 0. They say 7 times negative 7 is 0. Do you think that is 0? No. Positive 7 times negative 7 is negative 49 when we multiply. Yeah. But you just make sure that doesn't trick you when you're doing your rainbows. Now, when we combine like terms, this is like what I had just talked about. Why do these two cancel out? Good, because they're opposites. So our final answer would be 9b squared minus 49. Okay, I'm going to pause the video, and then I want y'all to ask me questions. And actually, I'm just going to stop the video.